Hello everyone, good morning. Welcome to this Kubernetes section. Today mainly we will be focusing on the stateful set. As of now, we have done or we have created pod in lot of ways. Like we have created a pod normally, like by using the Kubernetes kubectl run command. Then we have created a pod with replica set. Then with the help of deployment, with the help of daemon set. Okay, so these are the ways by which we have created a pod. Okay, and each and every object have their own benefits, or you can say own functionalities. So now a stateful set is also one of the object which we create in the Kubernetes, and internally it is going to create a pod. Now let me share with you a scenario where stateful set is going to be helpful for us. Okay, so let's consider that this is my front end pod. Okay, let's and these are the backend pods. Let's consider, let's say we have three backend pods, or you can consider this is the database pod as well. Okay, so I'll just name it as a db pods. And now you know directly this front end pod will not be able to communicate with the backend pods. Means let's say this is the front end pod, and if this front end pod want to communicate with this database pod, then we already know that we have to make use of the service, because direct communication is also possible, but these pods gets recreated always, so IP address will go change. So this pod will not be able to communicate on the basis of the IP address, because if this pod gets recreated, then this pod will have the new IP address. Okay, so communication over the IP address will not be feasible for us. Also, if we make use of the, let's say, a deployment, in that case this pod will get a random name. So if this pod gets recreated, again new random name will get generated over here. So in that case, definitely the connection or communication over the name is also not possible. It's possible, but it's not good to have, because these are the ephemeral pods. Now for that matter, we already know that we have to make use of the service. Okay, so over here we just make use of the service, and this service is nothing but a internal service, because this pod to pod communication के लिए we require some internal service, that is nothing but a cluster IP. Okay, and then to communicate with this front end pod as well, like we will need a front end service over here. Okay, so that we already know, because direct communication over the browser is not possible. Now let's consider a scenario where let's say you are trying to log into the Facebook for the very first time. Okay, let's say you are new to Facebook. In that case, you will not have username and password of that Facebook with you, right? So that's where you have to create your own account within the Facebook, so that you can go ahead and log in to the Facebook. Okay, so let's say this front end pod is nothing but a portal of a Facebook, and that portal is having some fields to enter, like name, email ID, address, phone number, and lot of things you have to enter while sign up. Okay, and once you fill all those details, so this front end pod is a way of providing a details, but in practically in real time, the details whatever you have mentioned, like name, phone number, all those things will go ahead and stay in the database. Okay, so enter your once you sign up with your all the details within this front end page, then this front end pod is going to communicate with this, means all those details have to be stored in the database pods. Okay, database. So let's say these are our database pods, and we have to go ahead and store the data. So whatever the data that you entered, automatically those data will get stored in one of the pod, because this pod is going to communicate with the cluster IP service, and internally randomly any of this cluster IP service is going to forward the request to any of the pod. So let's say first time cluster IP service forward request to this database pod. Okay, then this data gets stored over here. Let's say the name of the user is, let's say, a Subodh with some mobile number as 12345. Okay, so this data gets saved and some password as well along with the user. Okay, password, let's say admin 123 is a password. Okay, all those details I have stored or I have entered in the front end portal or Facebook portal for sign up, and those details are now stored in the database pod. So I'm good with this sign up page. Now next time, let's say if I go ahead and try to log in, let's say if I try to log in on the next day, in that case again I will go to that front end portal, Facebook portal, and I'll just click on the login page, and I need to provide username and password. Okay, so this front end pod is no longer having username and password anyhow. Let's say if you provide username and password, so this front end pod is going to check whether those are valid or not, because any username and password are not allowed. Only those are allowed which are stored in the database. Okay, so next time if I try to log in that case request again will go to the cluster IP service for validation purpose whether the provided credentials are matching or not which are stored in the database. Now let's say this time cluster IP forwards the request to the second database pod. Okay, because cluster IP is a load balancing service which can transfer or which can forward request to any of the following pods. Okay, so let's say this time this cluster IP forward request to this second database pod, and this second database pod is not having the sign up details. मतलब जो मैंने कल sign up में details enter की थी, all those details are stored in the first pod, not in the second pod. So this you can say this login page means I will not be able to log in to this Facebook application because this time internally request is went to the second pod, and this is the problem statement I'm having over here because this you can consider this pod is having this information. Okay, so you can consider this is the state of the pod depends upon what data is present within that pod. Okay, in reality pod में कोई data नहीं होता. Pod will connect to one of the persistent volume. Okay, let me show you, let me make that much that clear. Pod will have one database, not database, one of the storage, as we already know that how to create a persistent volume and how to create a PVC. So pod will be having connection to the PVC, sorry, means pod will have name to PVC, and internally PVC will connect to a persistent volume, and that persistent volume will have connected to a storage. Okay, so now this pod will have connected to this persistent volume, and same is the case, this persistent volume have this content within it. Okay, मतलब पॉड का स्टेट डिपेंड्स किस पे डिपेंड करता है कि उसके अंदर क्या डेटा प्रेजेंट है. मतलब पॉड को जो persistent volume कनेक्टेड है, so within that persistent volume what data is present. Okay, depending upon that the state of the pod we can say, because right now this second pod means these pods are identical, but second pod is not having access to this persistent volume. Second pod will have their own persistent volume. Each and every pod will have their own persistent volume in this case, because over here we cannot make use of the network file system as we have seen yesterday, because network file system is mainly for the storage of the files, but over here we are storing the data into the database. Okay, so database का जो data है we uh, cannot keep on the network file system. So that's why each and every pod will have their own persistent volume, and internally persistent volume will have their own storage. So let's say this first is, let's say, a PV1. Okay, so let's say this is a persistent volume 1, as this is the next persistent volume, let's say PV2. and this is the third PV. PV is nothing but a persistent volume. Okay, and each and every pod is connected to a storage, because anyhow let's say second user जब sign up करेगा, that time let's say uh, second user while sign up, if he connected to the second pod, in that case जो भी data होगा it is get resided to the second pod. Okay, let's say second pod persistent volume, let's say user 2 admin 2, this is the username and password, let's say. And while login, let's say login करते time if cluster IP send request to this third persistent volume, this third pod, in that case definitely login नहीं हो पाएगा. Okay, so such you can consider such applications, जो मतलब यहाँ पे अभी अपन लिख रहे हैं या फिर यहाँ पे जब पर कॉन्फ़िगर कर रहे हैं डेटाबेस का जो एप्लीकेशन है. ठीक है, ये डेटाबेस का जो एप्लीकेशन है, इस एप्लीकेशन को अपन बोलते हैं स्टेटफुल एप्लीकेशन. Okay, why we call it as a stateful application? Because the state of the pod depends upon what data is present within the persistent volume attached to it. फर्स्ट पॉड को PV1 अटैच है, उसके अंदर कुछ अलग डेटा है. सेकंड पॉड को PV2 अटैच है, उसके अंदर कुछ अलग डेटा है. So definitely there are some conflicts within that, and definitely if you make such architecture within the Kubernetes, things will not work. बिकॉज क्लस्टर आईपी का काम है कि कोई भी रैंडम पॉड्स को, मतलब जो भी 3 पॉड है अंडरलाइंग 3 पॉड्स, कोई भी एक पॉड को रिक्वेस्ट शेयर करे, आइदर फॉर storing the data purpose or either for validation purpose. But if that is the case, then each and every pod will have different credentials and different data, and I will definitely face login issues because I'm not sure internally data is stored on which persistent volume. Okay, so the state of the pod, it depends upon the data which is present within the persistent volume attached to it. So that's why we call it as a stateful application. Okay, so such database का जो application होता है, that will always a stateful application. But when we talk about nginx application, ठीक है, let's say अभी यहाँ पे database के pod नहीं है, nginx का ही pod है. So nginx is nothing but a front end, and front end never stores the data. Okay, फ्रंट एंड विल जस्ट टेक, फ्रंट एंड का काम यही है कि जस्ट टेक द इनपुट फ्रॉम द कस्टमर और एनी यूजर एंड स्टोर इट इन द डेटाबेस. दैट्स वेयर अपना जो nginx का जो एप्लीकेशन था, nginx एप्लीकेशन विल नॉट गोइंग टू स्टोर दिस डेटा. सो दैट्स व्हाई सच एप्लीकेशन इन विच the pod state doesn't depend upon the data present within that storage or persistent volume, such application we call it as a stateless application. Anyway, most of the time we deal with stateless application only because Kubernetes is very much easy or very much smooth in deploying the stateless application rather than the stateful application. In real time as well, even though this stateful applications are getting deployed by the front end, or sorry, stateful applications are deployed by the Kubernetes, but those are not maximum utilized. The thing is, we are making use of the AWS services for the database deployment because Kubernetes is not good enough to deploy the things which are stateful applications. Okay, and there are some alternatives like AWS may, we have some DB services, database services, so we can connect our Kubernetes to the AWS to store the data within the database, because AWS जो database का service provide करता है, that take cares of each and everything. That's where in reality in our project as well, we are not making use of stateful set, okay, just to deploy the stateful application because it's very much critical. I'll tell you the critical why it's very much difficult to implement the stateful set or install the stateful application over here. So the drawback of the having the stateful application deployment with the help of Kubernetes, now you can see like persistent volume will have different data. Okay, But definitely we have resolution of this as well, but that resolution comes with lot of trickiness and lot of, you can consider, it needs a lot of database knowledge to understand the things. Okay, now we know that this architecture is never going to work because cluster IP service is going to send requests randomly to any pod, and any pod will have the credentials or details of the users. So what I want, a single persistent volume should have all the details. मतलब अभी let's see how we can make this work in working condition. Okay, so what I will do, I'll just remove all those things and we'll show you how we can make this in a working condition. Means which all things we have to take care of to make this in a working condition. So let's consider again, Subodh login like sign up करता है. Okay, sign up करते time I will means I will write a code in a such a way that whenever there is data to be inserted, मतलब डेटा वैलिडेशन में क्या होता है, सिर्फ डेटा चेक करते हैं कि प्रेजेंट है कि नहीं डेटाबेस के अंदर, बट जब साइन अप करते हैं दैट टाइम डेटा डेटाबेस के अंदर स्टोर होगा. सो आई विल मेक श्योर ऑलवेज डेटा विल गो इनसाइड फर्स्ट persistent वॉल्यूम. ओके, लेट्स से यूजर वन लॉग इन किया, उसने सारे डिटेल्स प्रोवाइड कर दिए एंड दैट डेटा गेट स्टोर्ड इनटू द फर्स्ट persistent volume. As soon as the data gets stored within the persistent volume, I want the data to be in sync with next PV. मतलब सारे के सारे PV के अंदर वो डेटा सिंक हो जाए. यूजर वन का डेटा जैसे ही ऐड होता है फर्स्ट. So what I was saying, if any particular data gets inserted in the persistent volume 1, it should get synced with second and third persistent volume so that all the persistent volume will have the same data. ठीक है? So we are going to make use of the persistent volume for the write activity. Otherwise, let's say if let's say second persistent volume के अंदर डेटा सेव हो जाता है, देन सेकंड persistent volume को persistent volume 1 एंड pv3 से सिंक करना पड़ेगा. लेट्स से pv3 में डेटा सेव हो जाता है तो pv1 एंड 2 के साथ सिंक करना पड़ेगा. सो lot of overhead we are having, so that's where I will just simplify the thing and I will just keep persistent volume 1 for write activity. Okay, write activity मतलब adding the data within that, and I will keep pv2 and pv3 for the read activity, means for validating the data. Okay, in that case my architecture is little bit simplified. So always my data, whenever a new user will get sign up, that data will get always stored in persistent volume 1 and I will write a rule in the such a way that if there is any new data within the pv1, then automatically it will get synced with pv2 and pv3. Okay, so by this architecture we can see things are little bit okay now, but here is one more problem over here, that this cluster IP is not good enough for this architecture, because let's say a new user is going to sign up over here. Okay, this is the sign up request. Sign up request में we will get a lot of data like address, user, password, lot of data we are going to get. And what I want always, whenever there is a sign up request, it should be accepted by the first pod, because first pod को pv1 attach है. Okay, but cluster IP service क्या करता है, it just forward request randomly to any of the pod. cluster IP का काम नहीं है कि रिक्वेस्ट को चेक करे, एंड रिक्वेस्ट साइन अप है तो पहले पॉड को भेजे, रिक्वेस्ट रीड है तो सेकंड एंड थर्ड को भेजे. दिस इज नॉट द फंक्शनलिटी ऑफ द क्लस्टर आईपी सर्विस. इट इज गोइंग टू like transfer the request randomly to any of the underlying pods. So let's say even though there is a sign up request, that cluster IP can still send to this pod because it's not in our hand. This is how cluster IP is designed. So that's where cluster IP service is not feasible for this architecture, because I want whenever there is a request of sign up, always go to first pod. Whenever there is a request of login मतलब validate करना पड़ेगा username password correct है कि नहीं. For that matter, always go to second or third pod. Okay, so based on the request, I'm going to means I'm going to make use of first pod or second and third pod. So for that matter, we have to make use of the different kind of service, that is nothing but a headless service. Okay, this is a headless service. Now what is the difference? Okay, now at least you know that cluster IP is not good enough for our architecture, so that's where headless service comes into picture. And this headless service is mainly used for the stateful set only. Normally we never use headless service. This is getting utilized only with the stateful set to deploy the stateful application. Now, once I make use of the headless service, in that case, how I'm going to means how the request is going to get transferred. Okay, first of all, let me show you. Okay, so let's see what are the benefits of the headless service over here and what benefits it have over the cluster IP service. Okay, so for that matter, what I will do, we will just see some practical things first, so that uh, because if I tell you right now with just a theoretical things will not be that much clear. So that's why let's go within the practical and see what things are about the headless service. Right now, let's make use of this. Let's take any pod we have. We don't have any pod. This is the service by default service we get. And let's go ahead and open this statefulset.yaml file. As you know, we have this mini persistent. We will be making use of this persistent volume 1, 2, 3. So over here we will just create this persistent volume manually, and automatically this persistent the pods which are going to get created will have a claim, and that claim will get satisfied by this persistent volume. Okay, so we are not going to learn means we are not going to see a dynamic provisioning over here. We already saw it yesterday, so we will just go with the manual provisioning. So for that manual provisioning, what I will do, I'm just going to go ahead and create a persistent volume. So let's open the file with pv.yaml. Let's create a blank file, and I'm just going to provide a name of the persistent volume is, let's say, pv nfs pv0, and storage capacity is 200. As I'm having a single worker node, so I will make use of the read write once. And even though, let's make use of this, so nfs, so this is the this is the data, sorry, this is the location where this data will get placed. Matlab, if this persistent volume 0 is going to get attached to this db pods, in that case this db pod is going to write the data within the persistent volume, right? So that persistent volume, this is the location of that persistent volume where that data will get stored. Okay, so we will just try to keep simple things over here. Let's create few more persistent volume, because we can have as many pod as you want, because jitne pod hai utne persistent volume we will be required. So within this demo we will play with 3 pods, so that's where I will create a 3 persistent volume over here. So you can create within a single YAML file as well. This I haven't showed you till now. Let's say if you want to create multiple objects with the only single YAML files, then in that case just provide 3 hyphen option over here and write the thing one more time. Okay, so in that case, let's say the name of the persistent volume over here, I want it to be persistent volume 1, and this to be the directory for that. I want one more persistent volume. Let's copy paste the thing. So within a single YAML file you can create as many object as you want. Okay, it's not like only a single object is supported over here. So I have written a code for the 3 persistent volume. first persistent volume ending with 0, then 1 and 2, and this will be the respective locations. So let's save it. If you see pv.yaml, if I just applied the things, and 3 persistent volume got created over here. So you can see with the help of only a single pv.yaml file, we got 3 persistent volume created over here. And at what location they got created? srv, nfs, cube data. So you can see there are these 3 persistent volume pv0, 1, 2, 3. This was the previous one. Let me delete this. Not required. This default this is the previous one. So if at your end, let's say these directories are not created, then you can just create with the help of this option, and with this mkdir command pv0. If it's already exit, you can ignore, or if it's not there on your local system, then you have to create and make it to 777. So now we are good with this persistent volume. We like successfully created this 3 persistent volume over here. Now we will create a StatefulSet application with the help of Kubernetes, and that StatefulSet application internally will create 3 pods or 2 pods based on the replica we provide. Okay, so there are certain you can say features of the StatefulSet. Okay, let's say the shortcut of StatefulSet is STS. Okay, so if you remember in the deployment section, if you have replica equal to 5, then what will be the name of that all the pods? Let's say deployment name is mydep, replica set, let's say name is xs, and the name of the pod was like yy. Okay, so this name of the pod was not, you can say, confirm. This can be anything, because at the name of the means once you create a deployment and a pod gets created internally, the name of the pod can be anything, because it have the random characters within it. Okay, but this is not the case in, you can say, a StatefulSet. Over here, name of the pods will be like sts deployment name, let's say sts hyphen 0 ending with hyphen 0. जो भी आप sts का नाम दोगे, that will be the name hyphen 0. next का नाम क्या रहेगा? hyphen 1, then hyphen 2. Likewise, each and every pod will have a proper naming convention over here. Why we follow that, you will come to know later on, but these are the features. Means each and every pod will have a standard naming convention over here, and pods will get created in serial manner. It means not in parallel. So सबसे पहले STS 0 pod create होगा. Once that STS 0 pod got created successfully, then STS 1 create होगा. Once that gets successfully, then STS 2 create होगा. So creation of the pod is not a parallel over here. It's a serial manner. Then deletion also serial manner. It means, let's say if you want to remove one of the, let's say replica अभी मेरा 3 है, तो 3 pod बनेंगे with hyphen 0, hyphen 1, hyphen 2. If replica equal to, let's see if I make it 2, then सबसे last वाला pod delete होगा, मतलब hyphen 2 वाला pod delete होगा. So create होते टाइम ascending order में create होंगे, hyphen 0, 1, 2, delete होते टाइम descending order में delete होते जाएंगे. So these are some features of the StatefulSet, and each and every feature makes sense. You will get to know later on definitely why it is the case. Okay, now let's go ahead and create a StatefulSet for us. So persistent volume we already created, and let's go ahead and create a StatefulSet over here. STS, let me check if do we have any STS. I don't have any StatefulSet sts.yaml file. Let me explain the information which is mentioned over here. Okay, so this StatefulSet will get connected with a headless service. So this is the name of the service that I have specified over here. This is only specific to a StatefulSet. Okay, in deployment we never saw like service का अपन mention करते हैं, but in stateful set we have to mention this is how it works. Then rest of the things will be same as the deployment, like replica कितने होने चाहिए. This service we haven't created till now, I will create in a moment, but let's look into the stateful set. Uh, okay, so kind is equal to stateful set. Name of the stateful set I have defined as nginx-sts. This can be anything. I want two pods, and this is the selector section, we already know, and this is the template section where the pod specification is mentioned. So pod is going to get created from a nginx image over here, and whatever data that we are going to write within the pod at this location where www is going to get written within the persistent volume. So we know that first we have to create a persistent volume claim, use that persistent volume claim in a pod specification so that pod will get attached to a PVC, PVC will get attached to a PV, and indirectly we will going to write the data within a particular respective directory. Now the thing is over here, instead of creating अभी देखो यहाँ पे replica 2 है, तो I want 2 persistent volume claim to be created automatically. If I make it replica 3, so automatically there should be a 3 persistent volume claim to be created. And internally PVC will get attached to PV, and PV अपन ने already बनाए हैं, ठीक है. This is a manual provisioning. So that's where in case of stateful set you can have this template as well. What this template is about to do, this claim template, it is about to create a template as many pod as we have. If we have 2 pods, then this template is going to create the 2 claims. And claim के अंदर क्या part रहेगा? Storage class name manual, because we are doing a manual provisioning over here. Access mode read write once, and जो request है, I think I copied only till this storage equal to 100 MI. This I haven't copied. Okay, and this is the request. Okay, this is the storage request 100 MI. So now you can say access mode is read write once, storage class is manual, and request is of 100 MI. And we have created a persistent volume with the same configuration. Now if you just check over here, this is the persistent volume information, persistent volume. So we have storage class name as manual, capacity as 200, access mode as read write once. It means all the things which I have defined in the claim templates is getting satisfied. So definitely all the claims will get attached to a persistent volume, because whatever things I have mentioned is getting satisfied by a persistent volume I have just created earlier. Okay, so let's go ahead and go ahead and apply this YAML file, and automatically what is going to happen, 2 pod is going to get created. First pod get created, second pod gets created. What will be the name of the first pod? Name of the STS, nginx STS -0 will be the name of the first pod. And what will be the name of the second? This will be the name of the second pod. And you will see that these 2 pods will get created in a serial manner. Okay, keep serial apply -f sts.yaml. So you can see this is now only first pod is getting created. Okay, second pod has not started, and once this first pod came into the running, then only second pod started. Okay, so this is the feature that it provides to us. So it's like a creating a pod in sequential manner. Okay, so now both the pod gets into the running right now, but this was not the case in the deployment was about to create a pod in a parallel. Let's say 5 pod आपको बनाने हैं with the help of deployment, then all the pods will get created in parallel. Let's look into this persistent volume claim. Now you can see 2 claims got created over here automatically. First is this, second is this, and it is attached to the respective persistent volume as well. This persistent volume अपन ने पहले ही provision करके रखे थे, that's why, and whatever the things that we have specified in this claim as well, exactly all those things are matching, so that's where it got bounded. Now we have only 2 pods, so 2 pod इसलिए 2 claim create हुए, एंड दोनों के दोनों क्लेम अटैच हो गए. That's why in the first and second thing you will see the bound, but जो third persistent volume है it's still available. So once if I create one more pod of STS, in that case that will get attached to the third persistent volume as well. Okay, so it's always good to have extra provisioning of the persistent volume so that at any given point in time, if a new stateful set pod gets created, that should have a proper persistent volume attached to it. Now we'll look into the features. Now if I do kubectl get pod, we have two pods. Let's say if I make STS as, if I make replicas as 3 and let's apply it, so it is going to create the third pod as well. So this third pod is getting created over here, and this third pod will get access to that persistent volume as well. Okay, get PV. So this third persistent volume gets attached to this claim. Okay, so now each and everything is now bound condition, like all the persistent volume are bound to this persistent volume claim now. And now you know the naming convention as well. Name of the stateful set, this is the name we have defined, nginx-sts. So first pod name will be 0 1 2. Okay, and if I have to delete one of the pod, in that case just make replica, like let's say just make it 2 2 from the 3. Okay, 3 से अपन जैसे 2 बना देंगे इसको, and if I apply, so automatically one pod will get deleted. Okay, so which pod it is going to get deleted? That is nothing but the last one. Okay, these are the features. Okay, so now you can see we, this last pod gets deleted and we have only 0 and first. मतलब creation होगा तो like it will create -0 -1 -2 -3, likewise delete होगा तो last से delete होगा. ठीक है, so these are the features. Now let's talk about that headless service. Let's go ahead and create the headless service over here. VISVC, let's say. Name of the headless service that I am defining over here is a nginx headless. Labels doesn't matter, आप provide करो मत करो. This selector section matters. Okay, जो अपन ने pod बनाए थे with the help of stateful set, all those pods having this label. That's why I am adding selector equal to this run nginx. Okay, so that whenever a request is going to get accepted by this headless service, it should forward a request to those STS pods, and those pods are running over the port 80. So that's where I mentioned this port 80. One important thing over here we need to mention about the headless service, that this service will not have any IP address. In opposite to that, cluster IP service was having an IP address, but headless service will not have any IP address. Why it will not have? Let me show you a demo. Let's go ahead and create this file. If you just check kubectl get svc, this Kubernetes service was already there. Okay, this is a default service, and this is of cluster type IP. I mean, this is of type cluster IP, and you have the IP address to that Kubernetes service. But over here, if we create a headless service, the type will still remain a cluster IP, but that service will not have an IP address over here. Okay, why this is the case now? Because let's say if I just create any random pods, kubectl run p1-image nginx, and if I, let's say, go within that pod, ns lookup to this service, let's do ns lookup to this service, so it should show me the IP address of this associated service. ठीक है, so इस Kubernetes service के साथ this IP address is associated. Okay, ns lookup is not installed. Let's go ahead and install the thing, apt update, and let's install the NSLOOKUP with this apt install DNS utils. This is the package by which we are going to download a NSLOOKUP binary. Okay, now let's look into this NSLOOKUP Kubernetes and kubectl get svc. Now you can see this NSLOOKUP Kubernetes is giving me this IP address, okay, and this IP address is nothing but this IP address. So every time you request for a, or every time if you hit to a Kubernetes service, internally it is getting hit to this cluster IP service, and then cluster IP service is going to send a request to in following pods, any random following pods. But this is not the case with headless service. If you just check kubectl get pod hyphen o wide, and let's log into the pod p1 one more time, and this time we will just do ns lookup to ns lookup to this headless service. Now you can see this nginx headless service is not having any IP address, okay. So internally this is going to give the IP address of all the pods which are present inside it. मतलब headless service जिस जिस pod को भी request भेजेगा वो सारे pod के IP address we will get. Now headless service is going to get say transfer the request to this nginx, okay. So what is this STS के जो IP address क्या है, ending with 25 ending with 30. So that's where you got this ending with 25 ending with 30 over here. Let's say if you create one more pod, again that will come over here, okay. So nginx headless service, once you hit to this headless service, this is not going to directly transfer request to any of the underlying pods, okay. So let's go back to our this diagram and now understand the things in better way. Now we have seen lot of things in practical. Now let's jump to this theoretical thing so that all the things we have seen in the practical will get cleared. Okay, so let me delete this thing. Now we know that this headless service is going to share the IP address. Now let's say now सीक्वेंस में क्रिएट होते हैं एंड सीक्वेंस में डिलीट होते हैं, ऐसा क्यों होता है? लेट मी शो यू नाउ. इफ anyone, any particular user, let's say user 1 has done a sign up and user 1 का डेटा इस persistent volume के अंदर गया, then user 1 this persistent volume 1 will get sync with persistent volume 2, and जैसे ही 100% sync हो जाता है persistent volume 2 के persistent volume 1 and 2, then persistent volume 2 will get sync with persistent volume 3, okay. So this is a chain, okay. So first pv1 will get sync with 2, 100% होने के बाद pv2 will be in sync with pv3. So likewise जितने भी persistent volume होते रहेंगे, every time it is going to be in that situation only. Now let's say अभी मुझे delete करना है कोई, let's say if I have to delete a certain pod, okay. In that case, if this pod will get deleted, then associated PV will not be, matlab, then this pod will not have connection to this persistent volume 2. Similarly, if this will get deleted, then this PV2 will not be like there won't be any connection or communication between PV2 and PV3, because PV3 will always get sync with the previous persistent volume. PV2 will always get sync with the previous persistent volume, okay. And because of that, such random pod deletion is not possible over here. Matlab, let's say if you delete this random pod still, then in that case there will be an issue over here. That's where, as each and everything is happen in sequential manner over here, like syncing of this data and everything, so that's where आपको delete भी करना है. So if you delete this thing, it doesn't matter because we still have data over here, and always pv1 is going to get sync with pv2. बट आपने लेट्स से मिडल का ही मिडल का ही पॉड डिलीट कर दिया, सो देयर विल बी अ प्रॉब्लम ओवर हियर. सो दैट्स वेयर क्रिएट होते हैं तो सीक्वेंस में एक बार जैसे pv1 क्रिएट हो जाता है, देन pv2, एंड देन जैसे pv2 क्रिएट हो जाता है सिंक में हो जाते हैं दोनों, फिर pv3 क्रिएट होगा, फिर दोनों सिंक में हो जाएंगे। इस सिंक वगैरह का करने का काम we have to write a lot of application code for that matter, then only things will get synced with each other, automatically sync नहीं होगा कुछ भी, ठीक है। so that's where I told you इस इसको थोड़ा ज़्यादा टेक्निकल नॉलेज की ज़रूरत होती है to implement this, so that's where people choose to go to the AWS for making use of a database. But still, let's see uh, the architecture of this headless service and this stateful set. Now we know that why things get created in sequence and why things get deleted in sequence. Now अभी जो लास्ट चीज पेंडिंग है, that is nothing but how come this headless service will know that if there is a write request it should go to the pv1, if there is a read request it should go to pv2 and pv3. Okay, so this knowledge is nowhere we mention in the headless service. Okay, this knowledge we mention in the फ्रंट एंड पॉड, बिकॉज फ्रंट एंड पॉड को पता होता है कि रिक्वेस्ट साइन अप का है या फिर लॉगिन का है। साइन अप मतलब राइट रिक्वेस्ट, लॉगिन मतलब लाइक रीड रिक्वेस्ट। ओके, so front end pod know that request belongs to a write or read. Okay, in that case let's say this front end pod is going to communicate with a headless service. So headless service का फीचर है कि headless service खुद से कोई पॉड को रिक्वेस्ट नहीं भेजेगा। जैसे क्लस्टर आईपी सर्विस, नोड पोर्ट सर्विस इंटरनली was act as a load balancer and internally request was sent to the underlying pods, but headless service will never do that because random pod को request नहीं भेज सकते यहाँ पे, because there is a star mark on it. If there is a write request, go to pv1. So in that case headless service is going to provide the IP address of all the underlying pods. Okay, so as I shown you just now that once you connect to this headless service it is going to provide the IP address of all these pods. Okay, along with that it is going to provide the name as well. So based on all those details provided by the headless service, so abhi headless service is going to provide the name of the three pods to this front end pod. Then front end pod will decide which pod to connect internally. ओके, सो दैट्स वेयर फ्रंट एंड पॉड के पास वो लॉजिक रहेगा कि साइन अप किया तो विच पॉड टू कनेक्ट एंड लॉग इन किया तो विच पॉड टू कनेक्ट. सो ऑल दिस लॉजिक वी हैव टू राइट इन दिस फ्रंट एंड पॉड एंड लॉजिक वगैरह लिखने का काम वैसे डेवलपर का होता है. वी डोंट हैव टू वरी, बट वी शुड नो how things will work if we make use of a stateful application and deploy it via a stateful set. So small difference between the cluster IP service and headless service is cluster IP service will act as a load balancer and cluster IP service will have its own IP address, so that once we connect to that cluster IP service internally request will go to underlying pods, but in headless service request will not directly go to underlying pods. All the IP address of these pods will get shown to a front end pod and then it's his responsibility, फ्रंट एंड पॉड की रिस्पॉन्सिबिलिटी होती है मतलब कौन से पॉड को कनेक्ट करना है. इफ इट्स अ राइट रिक्वेस्ट like we have to write a logic within the front end pod that connect to a persistent volume 1, मतलब persistent volume 1 को नहीं, like STS0 pod को connect करो because STS0 is internally connected to a persistent volume 1. And what if I manually delete this? Okay, there is one more feature of it, okay, that I haven't explained till now. That feature is nothing but auto healing as well, but auto healing with having the same identity. It means if I just do kubectl get pod, right now you can see we have this name and this name over here. Okay, so in case of deployment if I delete any of the pod, that pod will get again some random names. Okay, but in case of this STS, if I delete this pod will hold its identity. Okay, because persistent volume is attached to it, so that's where the name of the pod will still remain same. if you just see 9 seconds before we got one pod created but with the same name. So these are the features of stateful set, that if you delete by mistake, if you delete any of the pod, that pod will get recreated with the same name, just because each and everything to be in sequential manner, and this is connected to a persistent volume again. If I just show you kubectl get pv, this sts is having a this sts0 is having a claim of pvc 0 pvc. This is the 0, this is the first number you can see, and this is connected to a first pod, and internally it is connected to this persistent volume over here. I know thoda matlab don't worry, the thing is in reality we rarely use this stateful set, but at least for interview purpose we should know what exactly is a stateful set. Mainly stateful set is used to deploy a stateful application like database. If you have to deploy nginx and all those things, just make use of the deployment as an object. Let's not go for a stateful set. And this headless service is only usable along with a stateful set. In normal scenario, we never use headless service. We only make use of it with a stateful set. I hope now you understood a little bit of it. Means what exactly the stateful set, what are the features of it, and how things will work if we have to make use of this database pods up and running in Kubernetes. Now, I hope this is good enough to understand. Now let's go ahead and look into one more type of container, that is nothing but a init containers. Okay, this it is one of the type of the container you can consider, that is a init container. Now let me show you one scenario so that things will get better clear. Let's say this is a pod, okay, and this is also one of the pod. Let's say this is a front end pod, not front end, let's say this is the back end pod, this is a database pod, okay, and this backend pod is going to get connected to a database pod. So let's consider that you are writing one application within it, and that application is about to connect to this database pod. So let's say this database pod को up आने में, let's say it takes 5 minutes, okay. In that case, this backend pod will not be able to connect to that database pod till the time database pod will be up and running, okay. So जब तक ये database connection 100% सक्सेस नहीं होता, till that time this application within the backend pod, it will keep on restarting, or it will be failing, because that application को सक्सेस होने के लिए database की connectivity is mandatory. And फर्स्ट 5-7 सेकंड के लिए जब तक के database connection सक्सेसफुल नहीं होता, for that time being this pod will be into the crash loop back off, or the container will keep on restarting. So in that case, what is the best thing to do? We can have one check over here, okay. So you know that within a single pod we can have multiple containers. So if we make use of init container over here, one is init container and one is a main application container, let's say app container. So instead of like checking that database connectivity from the application container, because application container check करेगा तो and उसको नहीं मिलेगा तो एक crash होते जाएगा, which is not good for us. So that's where we make use of the one more container, that is nothing but a init container. This init container is a short lived container, ठीक है. This init container will have certain tasks to perform it. Once that certain task get finished successfully, then that init container will get destroyed, okay. This is not like a application container, because application container will run 24/7 within this pod, but init container का काम होता है कि कुछ एक्टिविटी परफॉर्म करो, जैसे एक्टिविटी लाइक चेकिंग द डेटाबेस कनेक्टिविटी, ओके, सो इनिट कंटेनर डेटाबेस का कनेक्टिविटी चेक करेगा। जैसे ही इनिट कंटेनर को डेटाबेस कनेक्टिविटी का सक्सेस मिल जाएगा, then this container will get destroyed automatically and our application container will start, and this time our application container will not have any problem because database is already up and running at our end. Okay, so this is the one of the example of making use of a init container. One more example is like, let's say this application container requires certain files to be downloaded from a internet. Okay, so that is the dependency you can consider. So once that files get downloaded, then only application container will be up and running. So such dependency also can be performed by the init container. So we will give a task to a init container to download all those files from the internet and provide to a application container. And once that file will get downloaded, this container will get deleted and application container will start automatically, and that application container will have that files within it. So such small activities, instead of writing each and every logic within a single application container, we can segregate certain tasks in different container as well. And a container which is a short-lived container mainly for performing a certain activity, and once that activity will get finished, that container will get deleted. So that is the task of a init container. Let's look into in practically as well how things will work. So let's go ahead and first let's delete everything about this stateful set, and let's delete the service as well. Delete pod p1, and now let's look into the init container section. Let's go to initcontainers.yaml, copy this, okay. So what I'm doing, this is a normal, I'm creating a pod with a name init demo, and within that I'm having this main application container, that is nothing but created from nginx image, and I'm creating one more container within that, within the same pod. And just for simplicity over here, I'm making use of this slip command, okay, slip 20. So the thing is this in सबसे पहले मतलब whenever you create a pod, at start init container will get activated. Okay, so init container will get created within our pod first, and once init container will get finished, मतलब जैसे 20 सेकंड फिनिश हो जाते हैं, after that 20 second, that init container will get removed automatically, and then main container will get started. Okay, so this command can be anything, like command can be like downloading the things from the internet, checking for the database connection. So this can be any command. Okay, the logic you have to, like, it's up to a developer, it's up to us what logic we have to write within it, but just for simplicity we will make use of just a slip command over here. So this busybox container which will get created, that will get activated only for 20 seconds, because slip 20 जैसे finish हो जाएगा, then our main container will get started. Okay, so let's look into this in practically. Now you can see kubectl get pod, सबसे पहले अपना init container start हुआ, and we have only a single init container, that's why 0 by 1. So जैसे ही init container finish हो जाएगा after let's say next 5-7 seconds, then a new container, that is nothing but a container from a nginx will get started. Okay, so now this init will be gone in some time, and now you can see this pod initializing status and it came to the ready. So the next container that got created, that is nothing but a nginx container. Okay, so सबसे पहले init container ही trigger होगा, and till the time that init container doesn't finish his job, till that time main container will not get started. So these are the small description about the init container, and this is mean maybe you have to just remember 2-3 lines regarding init container, that this is a short-lived container. This is required only when certain tasks to be performed or certain dependency needs to be handled by another container. So in that case, just make use of init container, and every time you create a pod, init container gets triggered first, and till the time init container doesn't finish, main container will not get started. Okay, I hope you understood about this stateful set and init containers in great detail, and when we have to make use of both the objects. Okay, thank you so much for joining. See you soon. Take care. Bye bye.